Ladies and gentlemen, thank you for standing by. Welcome to Get the Most Out of OpenStack's Block Storage with SolidFire webinar. During the presentation, all participants will be in a listen-only mode. Should you wish to ask a question during the presentation, please use the chat feature located in the lower left-hand corner of your screen. If you need to reach an operator at any time, please press *0. As a reminder, this conference is being recorded Wednesday, November 19, 2014. I would now like to turn the call over to Mr. Aaron Dell. Please go ahead.
Hello, everybody. Good morning, good afternoon, good evening, depending on where you are in the world. I'm going to talk a little bit today about OpenStack and SolidFire, and really how we believe the match of the two of them is really complementary to each other. Quick introduction, my name is Aaron Delp. I'm on the solutions team here at SolidFire, and I'm specifically tasked with OpenStack solutions. What are we going to talk about today? Well, really three main points with a demo in the middle. The first point is the benefits of OpenStack and SolidFire, and really why the architectures are really designed for each other. The second point, and the second area we'll go into, is SolidFire and OpenStack, the actual integration details. We firmly believe SolidFire has the deepest, most complete OpenStack integration in the industry today. And to prove some of that, we're going to do a demo, a live demo, so there's always a chance things could go horribly wrong. We'll see. And then lastly, for those that really want turnkey OpenStack, we have a product and a reference architecture called SolidFire Agile Infrastructure, and we're going to talk about that at the end. So what we'll do is we'll go ahead and dig into the benefits of the architectures. And just as a reminder again, keep the questions coming, and what we'll do is we'll do some questions in between each of the sections as they come about, and then of course we'll have a Q&A at the end as well. And before we actually get into the benefits, I believe we have a poll. Is that correct?
Yeah, we'll actually have a series of questions throughout Aaron's presentation that we'll ask you. Shouldn't take too long here. Our first question is, what is your interest in OpenStack today? And we'll just give you a few seconds to answer the following question, or answer that question.
We have some responses coming in. Fantastic. It looks like we've got a nice mix across the board here among all of them. And we'll give it just a little bit longer here. And certainly thank you for your responses. That helps us with the presentation. All right. Looks like it's kind of settled down here. We're going to go ahead and close out the poll. And then go ahead and do close up top there. And I'll skip to the next one. Awesome. Thank you, everybody. What we're going to do is really talk about why we think SolidFire is the block storage platform for cloud computing. It really goes back to our origins. Cloud is really our DNA here at SolidFire. We were born out of the need for block storage at cloud providers. And we were specifically designed for massive cloud deployments, implementations at scale, where there's a lot of multi-tenancy and also a not necessarily an insight into those applications. And it's something we're going to really show you in depth as we go into the benefits. And along that same time, OpenStack really kind of reached a level of maturity in the industry, has been deployed at scale. And as you can see from the poll, a number of folks running in production, and really a lot of great success stories out there in the industry around OpenStack specifically. But what happens when you pair these two together? Well, it's not just about OpenStack. SolidFire here, we actually have a solutions organization, and we run a number of different solutions through this organization. And it has some unique advantages across the board. No matter whether we're integrating with OpenStack, CloudStack, VMware, we're doing databases, VDI. We're providing a single, scalable, shared infrastructure. And at the same time, once you start sharing infrastructure, how do you guarantee that performance? And how do you provide dynamic pools of resources? And that's what we're going to go into today. And that's really the origin of cloud orchestration and cloud computing. We started off with virtualization. And virtualization was very good, very successful in the market, but it really abstracted away the hardware layer in a very static model. And we keep hearing things about dynamic data centers or software-defined data centers or cloud computing. At the end of the day, these are all just words that mean the exact same thing. What does the next generation data center look like? And how do we provide dynamic pools of resources? So what we've done here is we kind of combined all of those solutions, and we came up with really 4 core benefits to SolidFire and cloud and OpenStack specifically. First of all, flexibility. We need to have that flexible pool of resources. Then once we do that, we need storage control. We need to be able to do that in a multi-tenant fashion. And then combine all of that together to provide time to value and time to market. So let's dig into each of those. We're going to talk a little bit about a benefit and then show you a little bit specifically in a SolidFire context what that means. So flexibility within OpenStack is dynamic pools of resources. It's this ability to take a large pool of storage, carve it up into both pools of capacity and performance, and really be able to adjust those allocations on the fly, really grow things and shrink things as needed. Check things out of a pool, use it for a certain amount of time, and check it back in. And at the same time, you don't want to be reconfiguring storage all the time. So you want to set it once and forget it. And really have the storage do automatic distribution and automatic load balancing. And so what does that look like in a SolidFire context? Well, what we have here is, it's a little bit of an eye chart, but down in the bottom corner in the gray, we have some of the all-flash arrays that are in this space. And what you'll notice there is they provide a large amount of performance, and performance is measured on the left-hand side, but not a lot of capacity, which is along the bottom. And then you have some of the more traditional storage arrays listed in orange, which provide a lot of capacity, but at the same or less amount of performance. And what we're trying to do here is show, with SolidFire, it's a true scale-out architecture. And what I mean by that is the ability to really add different nodes as needed, start small and grow very large over time, all under the same management interface and management plane. And what that looks like in a node architecture is this. We basically take a bunch of nodes and we store multiple copies of the data across the nodes. This leads to no single point of failure, and it leads to automatic self-healing within the environment. And what's really nice about all of this is we can actually fail a drive or even fail a node. A node is up to 10 drives. So we can actually fail up to 10 drives at once for the idea of unplanned downtime, if you will, of something catastrophic happens in the data center. We don't want it to happen, but it does. But at the same time, this same technology is used in hardware and software upgrades as well. If a new node type comes out and you want to go to it, it either has more capacity or more performance, we can add it into the existing cluster seamlessly. And if we want to retire nodes over time, we can pull them out and allow the cluster to rebalance itself and move on. And the same with software upgrades. Software upgrades, we can take one node out, upgrade it, put it back in. So non-disruptive upgrades are something we have done from the very start here at SolidFire. And it really is a core piece of our technology. And again, going back to cloud service providers and really anybody doing OpenStack at scale, you don't want an outage window on your storage. In addition to that, there's the concept of real-time replication, integrated backup and restore, and encryption at rest, all included in the package as well, either within a Cinder, OpenStack Cinder context or within SolidFire as well, and I can go into that. Now, that is the first benefit of scale-out architectures. Now, if you're going to combine a bunch of workloads together, how do you control it? How do you provide predictable performance, and how do you provide tiers of service to an organization. What you want to be able to do is provide predictable performance, whether it's mixing production with test and dev, mixing multiple tenants with an environment. How do you act like a service provider that can provide all of these various tiers of storage? And so this is how we do that actually in a SolidFire context. We prevent what you call the noisy neighbor effect. If you've done storage for any amount of time, this has been a common problem for a long time. I used to administer some of the more traditional arrays, and you absolutely have this, because what you can do at best is the idea of maybe putting a ceiling on some performance and really kind of limiting some of your workloads. But if you don't do that, you could have one workload or more workloads spike at the same time and affect everyone else there. And so what we want to do is be able to provide quality of service, a guaranteed level of service per volume, and also if we wanted to really provide SLAs or service level agreements, or really the idea of storage offerings. And that's what we're looking to do here. So we started with a scale-out architecture. We've now gone and taken the benefit of how do we predictably have performance around that. And we move on to the next benefit. The next benefit is multi-tenancy. A lot of times in our industry, whether it's a service provider, whether it's an enterprise that kind of wants to act like a service provider, multi-tenancy comes into play. And I'm not talking about different customers necessarily. It could be different workloads. It could be production and test dev. It could be different departments in an enterprise. Really, anytime you want to provide an end-to-end logical abstraction of physical resources, not just taking one big pool and carving out pieces, but actually taking those pieces and guaranteeing isolation between the different pools. But at the same time, you do want some things to consolidate. And what I mean by that is, in the all-flash array space, how do you get the investment to be maximized? How do you get the maximum amount of usable dollars per gig or dollars per IOPS? Well, we do this through many different techniques. Just simply by providing our quality of service, you're able to more highly utilize the array. By our scale-out technology, instead of having just two nodes and some disk shelves behind it like some other architectures that are out there, and if you really want to guarantee performance, you really can't go over 50% because you need to be able to fail over. Just built into our architecture is a lot of efficiencies, but at the same time, we also have what we call inline efficiency. Inline efficiency is deduplication, compression, then provisioning. Always on, always executed at a global level. So if you have common data across multiple tenants or multiple workloads, it will be used efficiently and effectively across the entire cluster. And if you combine all of these benefits together, this really wraps into the last benefit of honestly going fast. If you are in an environment where agility and rapid deployment are necessary, all of these features combined together really allows you to build and leverage a lot of workflows, instantly clone resources at zero cost, create test and development environments very, very quickly, and then if you wanted to just promote that development environment into test. A lot of these emerging concepts of DevOps or CI/CD, continuous integration, continuous delivery, things that leverage an API for automation. Everything that I will show you here in the demonstration coming up is basically OpenStack leveraging our API. And our interface leverages that same API. So there's really nothing hidden here. Everything that we want to do is all about creating the right tools to allow everyone to go faster and provide faster time to value. Now, I think we're on to another poll.
Yeah, we have one more, or this is actually the second of three. So what features are you interested in for cinder block storage with OpenStack? And we'll give you a few seconds if you just want to select one of the four options there. You can actually select multiple. All right. All right, so just a few more seconds, and then we'll go ahead and close the poll. All right, I think we're set.
Awesome. So yeah, nice even distribution across the board there, without a doubt. Great to hear. So I'm going to talk a little bit about all of these actually in all of this. So let's go to the next section. Before we go to the next section, though, I'm going to actually just pull up one or two questions, and then we'll move on to this. So there's really this idea of replication and backup. Somebody asked specifically, what about replications and backups? Because I did briefly mention both Cinder and SolidFire. So just to clarify that point, we offer within SolidFire in our operating system called Element OS, SolidFire native replication and backup. SolidFire to SolidFire, and then the instance of backup, SolidFire to S3 or Swift. And it's similar to, Cinder does have backup in it today. Probably the big key difference in Cinder versus SolidFire today is the ability to do incremental backups. Cinder backup today is full every time, and that's something that's going to improve over time, but just a kind of point-in-time reference for feature parity and differences. And with that, I'm going to kind of move on to the integration details here. So let's start with, for those that are unfamiliar, what is Cinder? So there's a lot of text on the screen. Honestly, here's an easier way to talk about it. Block storage that is attached to an instance. An easy analogy is a USB flash key that you plug into your laptop. It presents as another volume or another drive that is mounted and that you can store data on. And then when you unplug it, it is persistent, and you can plug it into another instance if you want it to. So the ability to attach instances, attach volumes, and then move them around is what we're talking about doing here. And there's a lot of talk in the industry around the whole concept of, we have an OpenStack driver, and some people, that's it, to be honest with you. Well, for us at SolidFire, this is about much more than having a driver. We fundamentally chose years ago to really go all in with OpenStack, and we're here to make OpenStack better. When OpenStack wins, SolidFire wins. OpenStack is our passion within the organization. And this gives us a little bit of a breakdown of the how and why. SolidFire was part of the team that led the creation of the Cinder project to break out from Nova block storage. The founding Cinder PTL was a member of SolidFire for the last 2.5 years. He recently relinquished the position to others within the community and has moved on now to the OpenStack Technical Committee. So really, how do we design and make OpenStack work across projects is some of our focus now going forward, as well as, of course, continuing within Cinder. We have a full, what we call native driver. This isn't a plugin. Because of that, every OpenStack release that is out there that pulls from trunk supports SolidFire, and very easy integration. We're going to show that here in a little bit. And in addition to that, this idea that we were talking earlier about setting quality of service, setting multi-tenancy, all of that is included, and we actually do it all from the OpenStack interface, not from the SolidFire interface. In addition to that, we've done a couple offloads. If you take snapshots within OpenStack, it's actually we offloaded and created a SolidFire clone, which I'm going to show you. And we also make bootable volumes within OpenStack very easy. And if you combine all of that together, the base message there is, this is really seamlessly scaling this after an initial configuration. And so what does that look like? I'm kind of building up to why all of this happens. And so there's one part of the demo that I'm not going to show just because it's already configured and it's honestly pretty easy. So how do you get OpenStack Cinder to talk to SolidFire? It's as easy as modifying or adding 4 lines to OpenStack Cinder.conf file. And all you're doing is telling it which driver to use, the management IP address, again, add it once kind of thing, and if you want to seamlessly add nodes behind that, you can, as you add more storage. And you're adding a login there and a password there to log in and talk to the SolidFire array. So since all we're doing is editing 4 lines, I mean, typically, honestly, configured in under a minute. You just do that, restart Cinder service, you're done. In addition, a very common question we get is, can you do multiple backends? And yes, absolutely you can. If you want to do Ceph in addition to SolidFire, if you want to do Cinder LVM, if you want to do multiple SolidFires, all of this is entirely possible. And we do that through volume types, which I'm going to go into in the demo. Before we do the demo, we have one more poll, and while we're doing the poll, I'm going to queue up some questions as well. So thank you. Keep the questions coming in, everyone.
All right, this is our last poll question. Thanks to everyone for participating. What configuration management tools do you use? And you can select multiple options here. All right, let's give you a few more seconds. All right, and I think we'll close the poll now.
Cool. Nice kind of across the board once again. So thank you very much for that. I'm going to kind of work those into the presentation as we go. What I'm going to do is I'm going to actually flip over and kind of do a quick demonstration here. Little bit of kind of introduction to the demonstration. A little bit of kind of what you as an OpenStack administrator would typically do and configure. And then what does it look like when you're an actual user as well. So I'm going to go and share out my desktop here. And you should be seeing an OpenStack Horizon dashboard. Here is my SolidFire cluster. And then lastly, here's, of course, good old command line for OpenStack. So what I'm going to do is I'm going to start here. Think of me as the OpenStack administrator. And what I'm going to do is show you how we kind of configure everything. So if I do Cinder, extra specs list, this is how we actually do the entire concept of storage service offerings, if you will. We use OpenStack volume types, and then we leverage the extra specs off of a volume type. So this is effectively a template or a service offering. And we have different levels of performance, and we have names here. And so, for instance, right here, SF for SolidFire, slow, 100, 200, 250. Well, you'll notice here, minimum IOPS, 100, maximum IOPS, 200, burst IOPS, 250. I'll explain burst very quickly. We do allow the system to kind of build up credits, if you will. If you're below your maximum and you need to burst above that maximum for a short amount of time, for instance, like VDI boot storms or Oracle queries that need to run or something like that, that will typically be bursty, but will be for a short amount of time and then go back down, that's where we set that as well. Well, these are our various service offerings. And why I'm here, by the way, at this as opposed to the dashboard is these volume types and setting these extra specs. This, as of today, this isn't exposed in Horizon. That's why I'm here. So a lot of the rest of the demonstration is going to be from the Horizon dashboard when I'm kind of the tenant or the user. But if I wanted to go create one, I can just go Cinder type create, and then I'm just going to call this SF super fast. And then I'm going to say 1200 as a minimum, 2000 as a maximum, and 3000 as a burst. Now this is just a naming convention. I haven't actually set anything yet. If I go look at my extra specs again, you'll notice extra specs is blank for this one I just created. The reason for that is basically I haven't specifically set the extra specs yet, and so it's pulling the defaults. And SolidFire defaults are, I think it's just a minimum of 1,000 and maybe maximum of 10,000, something like that. So it is setting something. It's just not setting necessarily what we want it to do. And I'm just going back in my history here for the command to actually set those, just because it's kind of long. But just to explain here, what I'm doing, I'm setting my minimum IOPS to 1200, I'm setting my maximum IOPS to 2000, and I'm setting my burst IOPS to 3000. And now, if I go look at my extra specs, for super fast, it now has the parameters that I wanted. And that piece is really done. As the OpenStack administrator, I've now set the volume types that I need. So if I flip back over here, and as the administrator for a second, go check volumes just to kind of show you when I scroll down to volume types. Here is my volume type that I just created. And here's all of the other volume types in the system as well. Well, now if I go up to kind of the tenant or project level, and I go to volumes, let's go create a volume and kind of tie all of this together. So I want a super fast volume. And I created a type of super fast. So the drop-down menu is obviously populated by the volume types that exist in the system. I'm going to create, I don't know, we'll just call this 40 gig. And I'm not going to do from source or anything like that. I'm going to create that volume. And while it's often creating that, I'm going to show the bootable aspects at the same time. So what I'm going to actually do is create a bootable one. So I'm going to do SF bootable. I'm going to just say, I'm just going to call this medium. And 20. And then this time I'm going to say a source. I'm going to say image from my repository, and I'm going to create that volume. And it's downloading it. It's going to go off and create it all. And in the meantime, let's go look at what that actually does on the SolidFire side. So you notice we've got, this is it pulling it down out of the repository. We've got some traffic going on our nodes. If I go over to volumes, and I sort by volume ID, this is the most recent ones first. You'll notice it looks a little ugly, but at the same time, this is very effective when it comes to tying OpenStack together. But one thing to look at too, again, in true multi-tenancy aspects, I'm running SQL workloads on here, which is these SQL VMs down here. I've got some CloudStack listed as here, the CloudStack attached to this as well. And I've got more than one OpenStack account on here. This is where the multi-tenancy aspects of this comes into play. For every tenant or project in OpenStack, we create a SolidFire account, a one-to-one mapping of tenants and projects to accounts. And then we create that volume name with the UUID of the actual volume that it's created. So you notice I just created a 40 gig volume. This is the UUID that we can show you back in the interface. This is the UUID of the other one I just created. And so what I can do to show you the quality of service, you notice right here, this is my medium level offering. It has set it. This is my super fast. It has set it. And if I want to see just all of the ones that belong to me, 699C is me. I have 7 active volumes right now, and so I want to see just my volumes. I can click on this. I can reverse sort it to get the latest volume IDs, and again, here they are, right here. So very easy to show in the SolidFire interface the correlation between OpenStack and SolidFire. Something else I can show you as well, if I go over to command line again and just do Cinder list, you'll notice here, I apologize, I think this is in the way. I don't know if I can move this or not. There we go. Is that moving on the screen? Yeah, there we go. SF bootable, that volume I just created. It is a medium volume type, bootable true. So we went ahead and set this all to true. You can go ahead and just attach it to an instance. It's not attached yet. And we're off and running. Super fast. Volume type, bootable false. So again, depending on how I created that volume, we went ahead and did everything we needed to go ahead and set everything bootable in the background. Very easy from an operation standpoint to show all of that. Now, if I go back to the OpenStack interface, if I wanted to, I can just go ahead and attach this. Oh, log out. Sorry about that, I wasn't quick enough. And I'm willing to bet you it's going to be 2 logins. Oh, it logged me back in. All right. Sorry about that, everyone. If I go to my superfast, edit attachments, attach to me. This is an instance I created earlier. Attach the volume. It's going to attaching, and it's going to say this is the one I'm actually attached to. What if I want to take a snapshot? And this is where we again we do some additional kind of secret sauce above and beyond. If I go create a snapshot, and I'm going to force it because it's attached to an instance. I'm just going to force it. I have a volume snapshot. It's creating. It's done. What does that look like in the SolidFire interface, and what happened under the covers? Well, I will have created a new volume. I have volume ID 340. You'll notice my account is me. I have a new UUID. So it actually created a new volume. We offloaded that snapshot to us and did a clone. We did a SolidFire clone of that volume. I also cloned his volume type or quality of service. What if this was production and I just want it to test out? And I don't necessarily want it to run as fast. I can just do a retype of this volume. So I could retype this medium, slow, whatever I want it to, and actually kind of cut that performance down to make sure when I create a clone, it isn't going to be of the same performance level as needed. And if I go look at the volume details of all of this, again, always trying to have very easy track back and accountability from OpenStack to SolidFire. You'll notice here is clone, true, and then source. This is the one it was actually cloned from. So always providing that audit path and trail back, if you will. This idea of a direct mapping from our interface to the OpenStack interface. And that's really kind of the end of the demo that I wanted to show. What I'm going to do is I'm going to stop sharing and kind of flip back to the presentation now. And we'll get to some questions here before I move on to the next section. But I just wanted to kind of reiterate what we saw there. The idea of storage service offerings by creating volume types as the OpenStack administrator, and very easy configuration of that Cinder driver. The idea of both a bootable and non-bootable and their attachment. The offloading of snapshots into SolidFire clones. Multitenancy and insight into that multi-tenancy built in. And at the end of the day, I showed you the SolidFire interface just to kind of prove that it was there and that we actually did what we said we did. But it 100% entirely managed from within OpenStack. And with that, I guess we'll flip over to some questions here. I'm going to look through some here real quick. So the first question, I'm going to kind of take a couple, and I'm going to save a couple for the end. Does SolidFire not require any form of driver config at the hypervisor node. That is correct. That is absolutely correct. Everything is handled within the Cinder.conf and just kind of restarting that and kicking it off. It's what we kind of call a native driver versus a plugin. So absolutely, that's all we need to do there. The next one is when the SolidFire driver is present, does Horizon expose new capabilities, volume snapshotting? That's a great question because it's very subtle. The Horizon dashboard, the way it is today, is kind of the Horizon dashboard. And we plug into Cinder, and we actually kind of take some of those Horizon calls, like for instance snapshotting is the prime example, and change it into something on the backside, like a SolidFire clone. So I wouldn't say necessarily like we don't modify Horizon, at least not today. We kind of do everything behind the scenes, if you will. And with that, I've got some other questions, but I'm just going to blast through these last couple slides, and then we're going to answer them all at the end. The last point I wanted to talk about today was what we call SolidFire Agile Infrastructure. So what is that? Well, SolidFire Agile Infrastructure is nothing but a series of pre-validated, pre-configured infrastructure reference designs. And it's designed to be very modular in nature. But one of the reasons why I asked earlier kind of what tools are out there and what you're using today. Because we do have orchestration layer in all of this. And so what we're actually looking to do is take a bunch of common pieces, because a very common question we get is, OpenStack at times takes a little bit more when it comes to standing it up and really getting it going out of the box. And so we want to make this as turnkey as possible. And again, we're all about kind of time to value for everyone within the organization. And so what we've done is, in conjunction with Dell and Red Hat, released a reference architecture that is based off of Dell hardware and Red Hat software, and combining them all together and really creating what we call Turnkey OpenStack. And so this leads to some great operational benefits of Agile Infrastructure. Because of that, you get that whole concept of software-defined and dynamically allocated pools of compute, network, and storage. We're able to go from bare metal to OpenStack within 30 minutes or so. Install and configure OpenStack in another 30 minutes. And linear scalability of just plugging in compute and storage nodes as you go. And at the end of the day, being able to really operate this efficiently at scale. And so with that, before we kind of go into all the questions, what's kind of the core story here? Well, validated interoperability. Working with many of the players in the OpenStack community, Rackspace, OpenStack, Nebula, Mirantis, Red Hat OpenStack, and great customers that are out there that we work with today. Some very large OpenStack implementations that are out there are powered by SolidFire and have been for quite some time. And this idea of just adding as you go and seamless upgrades are some of the key features that they're looking at. And with that, we'll kind of flip it over to questions very quickly. Okay, I'm going to take a couple of them in turn here. First one, does Cinder and SolidFire support multiple storage systems at the same time? Yes. I apologize if I wasn't more clear on that. It's actually a common question. In that Cinder.conf file, you can absolutely specify multiple backends. We actually, in our lab, have multiple SolidFire backends running as well as LVM as well. So when we kind of need to flip back and forth from an interoperability standpoint, that's actually how we do all of our testing today. Next one was, can you change a volume type? Yes, absolutely you can. You cannot do it from within Horizon though, and that kind of goes back to the other question of SolidFire exposing features within Horizon. There is a retype command, a Cinder retype from the command line that you can do. So you can very easily retype and do performance. And it does it on the fly. So if you have a volume or an instance that's attached to a bunch of volumes and you need to reclassify that performance, either bump it up or down, you can absolutely do that dynamically. How does SolidFire to Swift backup work? So that's a fantastic question. And actually what I can do is I can give you kind of the high-level overview of it, and then if there is additional questions, I would actually say email me directly, and I can certainly get you in touch with some of the folks that are doing all of the integration and backups. I don't have that as part of my demo today, but it really is as easy as setting it up against a Swift target, and then it just kind of does a dump in, and it's of course a full backup the first time, and then we can put it on a schedule and do incrementals after that as well. And I apologize if that doesn't completely answer your question, but certainly hit me up if that doesn't, and I can get you more details. Does SolidFire only sell SSD-based systems? The answer to that is yes. And the reason for that actually is slightly non-intuitive. It isn't to go fast. A lot of all-flash arrays that are out there in the industry today use all-flash to kind of go fast. Think of it as, you know, a dragster down a drag strip of one application going really fast, or I'll apologize ahead of time for a horrible joke. I'm from North Carolina, kind of home in NASCAR country. It's not like a car that goes really fast that just turns left. Right? We're designed to be more than one thing. And the only way to get guaranteed performance across multiple workloads and be able to do that predictable quality of service is with all flash. Because we have a predictable amount of performance, a predictable amount of latency to the writes, we can guarantee that we know what kind of performance we are looking at so that we can pool it all together and then dynamically allocate that out. If you could do the same architecture in spinning disk, we probably would, but you can't. Rotational latencies of drives, all the many limitations of traditional disk systems that are out there today. You just aren't able to achieve the architecture goals at the end of the day that we are looking to achieve. And that is about it for questions. So if you have any more questions, I'd say submit them. We've got a couple more minutes before we kind of shut this down. And I kind of run into the conclusion. So we'll just kind of, what I'm going to do is I'm going to flip to my conclusion slide. And if you have any more questions last second, let me know. But what did we talk about today? Well, we talked about the benefits of OpenStack and SolidFire and really how the architectures are made for each other and kind of grew up together, if you will. And very, very complementary in their benefits they provide. Second, we talked about integration details and really why OpenStack integration, again, we firmly believe this is really all about deep integrations provided very easily for very easy operations. Now, and lastly, the idea of turnkey OpenStack. What if you aren't quite comfortable with where you're going today? Well, what we can do is really provide the SolidFire Agile Infrastructure as that last idea of a reference architecture that's pre-configured, pre-validated, and we know will work. And so lastly, there's some links up there. I'm going to leave those links up there, and then we did get some last questions that came in. Thank you very much. So I'm going to talk a little bit about those last couple of questions. So the website says you can get a starter solution for less than $100,000. And again, this goes back to probably price sensitivity as one of the big issues in the poll earlier. Is that possible with SolidFire? and how long is it going to take to really get something and kind of get it up and running? So I talked about, and that's actually a great question because I've talked about how easy it is to get OpenStack up and running, but that kind of assumes that SolidFire is already up and running. So first of all, yes, base configuration, couple node minimum, 4 node minimum specifically, available for under $100,000, and getting the SolidFire up and running is really as simple as putting them all together, kind of joining everything into the cluster, and then providing a what we call a storage virtual IP and a management virtual IP. So configuring, what is the IP the storage talks to, and what is the IP the management talks to, and you're up and running. So not only is it an easy integration from OpenStack to SolidFire, but it's also an easy integration to just stand up SolidFire to begin with. Next, is there a demo system that folks can play with? There is actually, but it would request going through the local sales channels. We actually have demo systems, and actually I was giving you my demo from one of our demo systems. And so that is entirely possible. It is a system, we have multiple systems set up running all the time to really, if people want to kick the tires a little bit, put their workloads on it, and figure out exactly, is this really what we say it is? We absolutely have those systems available. If you don't know who your local sales contact or SE contact is, again, shoot me an email and I'll be more than happy to point you in the right direction. Lastly, SolidFire ephemeral storage. The short answer is yes. The long answer is it's a little complicated and probably beyond the scope today, but it's a fantastic question and a common question we get. Can you use SolidFire for ephemeral? Absolutely. Most of our customers today don't, to be honest with you though. Most of them typically will do some kind of local storage for ephemeral. Your results may vary. You can absolutely architect it all you want in a bunch of different ways. It just depends on what you want to achieve at the end of the day. And again, very common question, and thank you for that. And so I think with that, we are out of questions, and we're almost out of time. So thank you very much, everyone, for sticking with us today. Thank you for participating in the polls and the questions. We certainly hope this was very beneficial to you.